We are familiar with equations having their solutions as some real value for the variable x. X plus 7 equals to 10, for example, has the real value solution x is equal to 3. So this has one solution. An equation may also have two solutions. A quadratic equation, for example, x squared plus 5x plus 4 is equal to 0 has two solutions. X is equal to minus 4 and minus 1. So this has two solutions. An equation may also have infinitely many solutions. Sin x is equal to 0 has n pi as its solutions. X is equal to n pi. Because n can take all integral values. N is an integer. So this could be minus pi, minus 2 pi, 100 pi, 0. All of these values satisfy this equation. So this equation has infinite solutions. A differential equation, on the other hand, instead of having such real value solutions for the variable x, have their solutions that are functions of x. Differential equations have solutions as functions of x. For example, y is equal to sin x may be a solution to a differential equation. Y is equal to e to the power x. Y is equal to 1 over x, and so on. These equations ask the question, what value of x satisfies this equation? And your answer might be a real number or multiple real numbers for these cases. Well, a differential equation, on the other hand, asks you the question, for example, what function, when differentiated twice, gives back the negative of itself? Or written mathematically, d squared y over dx squared is equal to minus y. This mathematical notation is just the shorthand for this long question. So you may point out that, well, y is equal to sine of x has such a property that when you differentiate it once, you get minus cos of x, and if you differentiate it again, plus cos x, and you differentiate it again, you get minus sin x. So you land up with the negative of what you began with. You may also point out that y is equal to cos x, in fact, also has the same property. Cos x differentiated once gives minus sin x, and differentiated again gives minus cos x. So this also has the same property. You will see that y is equal to a sin x or a cos x has the same property because differentiation does not affect this scalar. If you look even deeper, you will realize that y is equal to a sine of x plus some other constant, which is known as the phase, also does not affect the solution and the behavior that we are looking for, because this part is also not affected by such a function, such an operation, that is differentiation. So this expression encompasses all the possible solutions to such a question. D squared y over dx squared is equal to minus y. What values of what functions are such that differentiating them twice gives the negative of those functions? And this is known as a general solution. For this differential equation, these individual solutions are what are known as particular solutions. You see, sin x and cos x only differ by a phase difference of pi by 2. So an appropriate value of b, pi by 2, would take care of both of these particular solutions. Furthermore, these positive and negative signs will also be taken care of by this constant a. So this solution is known as a general solution because it encompasses all the possible values, all the particular solutions of the differential equation. In fact, this equation has a special name. This is just a modified version of the wave equation, which we come across quite frequently in physics. And this, you will see, is the equation of a wave, the solution to a wave equation. So this equation that we have, y is equal to a sine x plus b, we can plot it in some free graphing calculator. I'm using Desmos here, for example, highly recommended. So we type in y is equal to a sine of x plus b, and we'll add these arbitrary constants. These are known as arbitrary constants, by the way, a and b, into this calculator. So the function, the value a represents the amplitude of the function. So varying a would change the displacement of the wave from the mean position. B, on the other hand, tells you about where the wave began. So varying b changes the position of the wave in the x-axis. And this is represented by the equation that we began with. d squared y over dx squared is equal to minus y.